So now let's talk about the structure of glucose, galactose and mannose. Right, first of all we will look at the straight linear structure and then we will be going through the ring structure of glucose too. Like the general formula of 6 hexose sugar is C6H12O6, right? And these three are isomers. They are having same formula but they are having different structure, right? So here carbon number 1, carbon number 2, carbon number 3, carbon number 4, carbon number 5, carbon number 6. Here carbon number 1, carbon number 2, carbon number 3, carbon number 4, carbon number 5, carbon number 6. Here OH. And you have to learn this formula, like how to create glucose. So this is the this is the structure of glucose. As you can see over here, like it is having OH on all the OH are on the right side, but on the carbon number 3, right, the OH is on the left side. So there is the structural difference between OH. Always remember there is a difference between OH, right? Now let's talk about galactose, right? Here OH, OH, OH. So you can see over here, like all remain same, carbon 3 H is here, but at carbon number 4 OH will be placed on the left side, right? In glucose on carbon number 4 the OH is on the right side, but now in galactose the carbon number 4 OH will be on the left side, right? So there is a difference between OH at carbon number 4. Right, now let's talk about mannose. So as you can see over here, this is the structure of mannose. There is a difference at only carbon number 2. It is same as rest in glucose. The OH is on the left side. So now look at the basic difference. In glucose, in carbon number 3, H is there and OH is here. In carbon number 4 is OH is there and H is there, right? This is glucose, right? When talk about galactose, H is there, OH is there, but this is galactose. At carbon number 4 hydroxyl group is on the left side. Okay, when we talk about mannose, at carbon number 2 this H is over here, it is OH is over here, H is here, OH is here and OH is here and H is here. So in mannose we will compare mannose with glucose, not with galactose, right? So at mannose at carbon number 2 H will be on OH will be on the left side. We will always see OH group. So now glucose, galactose and mannose, these three are aldehydes. You can see what is the general formula. First of all, let's remind it what's the general formula of aldehyde. The general formula of aldehyde is RC double bond. So this is the general formula of aldehyde. So if you can see over here, C double bond O H H. Oh, C is aldehyde. C double bond O. Okay, now C double bond O is known as carbonyl group, right? C double bond OH is known like it's aldehyde. C double bond OH is aldehyde. So these three are aldehyde. So now we will say these three are aldose. OSE means sugar. Now which sugar? They have aldehyde group, so now they will known as aldose sugar, right? So now let's talk about the ring structure of glucose. Like, for that purpose, you must know that the second last carbon is very clever, it's very mischievous, right? He, like, the second last carbon is he's always doing something clever, something mischievous over here. So it's just a story to make you understand this. This is oxygen. This is carbon number 1, carbon number 2, carbon number 3, carbon number 4, carbon number 5, carbon number 6. So we have placed carbons. Now we will place OH. If OH is above and H is at downward side, we will say this is beta glucose. If, and the carbon will be carbon number 1. If at in a ring structure at carbon number 1, OH is on the upside and H is on the downward side, like we will remember OH only, and so you can easily it will be alternate of H will be the alternate of OH. So at carbon number 1, OH will be on the upward side. This is known as beta glucose. Here OH, H, here OH, H, OH, H, here OH, H, OH, H, H. So this will be the ring structure of beta glucose. Now if you want to talk about alpha glucose, right, what will be the structure? O, carbon number 1, carbon number 2, carbon number 3, carbon number 4, carbon number 5, carbon number 6, and here H will come, OH is here. So all the carbon will be having same OH and H, but they will be only changed at carbon number 1, right? Carbon number 1. So when at carbon number 1, OH is on the downward side, so it is known as alpha glucose. Like at whenever the OH on the carbon number 1, must remember that this is carbon number 1. So whenever the OH group is on the upward side, it is known as beta glucose or beta whatever the compound is, and when the OH group is on the downward side of the carbon 1, it is known as alpha glucose. I hope this concept of alpha glucose, beta glucose, there's a ring structure. Okay, whenever we dissolve the glucose into water, at that condition, at that moment, it changes its structure. It from linear structure, it comes into ring structure. So obviously this is the ring structure, and this is a linear structure. So whenever we, like at the dry, this is linear, but when we dissolve this linear structure into the water, it will become this ring structure, right? So I hope you understand the concept of how to make structure of linear structure of glucose and the isomers glucose, galactose and mannose. Okay, what about glucose and galactose are epimers, and glucose and mannose are also epimers. And I like, for to understand epimers, you must have seen my previous video on epimers, diacetylsomers and enantiomers, like because whatever epimers, there is a changing of OH, like both compounds are same but there is only change in OH. So obviously you can see at glucose, carbon number 4 both are same as carbon number 3, H, OH, H, OH, but at carbon 4 only the position of OH is changed, so it means these are epimers. On mannose, like both are same but at carbon number 2, here carbon number 2, OH is here and H is here, so OH is placed on the left side and here OH is on the right side. So these mannose and glucose are epimers, and glucose and galactose are also epimers. So I hope you understand the concept of how to make a linear structure and how to make a ring structure, the concept of epimers, carbonyl group, beta glucose and alpha group. Like whenever OH will be at downward side, it is known as alpha glucose. Whenever the OH will be at upward side, it is known as beta glucose.